Welcome to the course on power quality. So, we will cover today the topic on passive power filter. Well, coming to the outline of the today lecture, we will like to introduce this passive filters, then we will talk about state of art on passive filter, then we will talk about classification of passive filter and principle of operation of passive power filter, then analysis design of passive power filter and modeling and simulation of passive filter, then limitations of passive filters, then the parallel resonance of passive filters with supply system and with numerical examples summarized and references. So, that is the outline of the presentation. So, coming to the objective of this lecture, we will like to talk about first requirement and application of passive power filters, then we will talk about configuration of passive power filter. We like to learn about the design, we will like to cover the design of passive power filter and then modeling and performance of passive filter, limitations of passive power filter, and we will like to talk parallel resonance with supply system on passive filter. So, coming to the power quality problem due to nonlinear load, last lecture we covered the nonlinear load and what these nonlinear load cause the problem. They cause the increased RMS current, they cause the increased losses typically low system efficiency, then the poor power factor, it causes poor power factor, they cause the poor utilization of distribution system, they cause the heating of components of distribution system, and we like to have a derating of the distribution system and we will have a distortion in voltage waveform at PCC and interference to communication system, then distribution to nearby consumers. And the solution of course, for these problems which are caused by nonlinear load in the distribution system, the solution are kind of like a conventionally traditionally there have been like a passive power filters, we call it in short PPF, and or it can be active shunt filter and active series filter and hybrid power filter. So, we will like to cover these topics in the next forthcoming lectures and if we coming to a classification of this power filter, typically you can call it the power filter can be classified into passive filters, then the active filters and the hybrid filter. And passive filter can be of course, you can have a shunt passive filter or you can have a series passive filter. Similarly, active filters also can be active shunt filter and active series filter, and hybrid can be a hybrid of passive passive or it can be hybrid of active passive or it can be hybrid of active active. So, this is the broad classification of the power filter which are used for mitigating the power quality problem in the distribution system or even a part of the transmission system like HVDC or other kind of converter where you have a power quality problems caused by harmonics generated by the different converters and nonlinear load line. So, coming to the applications of passive power filter, in high power rating such as HVDC system due to these passive power filter are used in high power rating such as HVDC due to simplicity, low cost and has a robust structure and benefits of meeting reactive power requirement in most of the applications at fundamental frequency, because this thyristor converter which are used in HVDC they require reactive power also along with the harmonic mitigation. So, this passive shunt filter can provide even the leading reactive power also which these converters require for. Well, they are extensively used in hybrid configuration, major portion of filtering is taken by passive filters. Hybrid may be like a active shunt small active series filter by passive shunt. So, we will talk about when we will talk about hybrid filters, we will talk about this topology. The reason why technology have moved in that direction. So, we will like to talk about that also. Then in medium and low power rating, especially in distribution system because of their low cost and simplicity, this passive power filters are used. And well, the one of the major problem with this typically passive power filters is the parallel resonance with the supply system. Why this is a parallel resonance, we like to explain with the examples also later on, but I can just explain little bit in brief. The passive filters become very sensitive to the parallel resonance between the capacitors and the capacitors of passive filter and the source impedance, which is highly inductive in nature, mainly inductive in nature. and if the parallel resonance frequency occurs at or near a harmonic produced by the load, a severe voltage distortion and harmonic current amplification may be produced, and it may result in nuisance, fuse blowing and or breaker operation. Therefore, utmost care must be taken in the design of passive filters to avoid such as parallel resonance and associated problems. And however, if these passive filters are used along with the small active filter which blocks or avoid the parallel resonance, well, coming to state of art on passive power filter, I mean the state of art is the passive power filter technology is mature by providing compensation for harmonic current, reactive power in AC network, and passive filters are also used to eliminate the voltage harmonics, to regulate the terminal voltage, to suppress the voltage flicker, and to improve the voltage balance in three-phase system. They are classified based on tune, or they are whether these are tune filter or damped filter. We will talk about little later about this. So, this is one classification. The second classification based on the connection, whether they are connected in series or parallel, or you can call it in shunt, and the supply system typically like whether they are used for single phase 2 wire system or 3 phase 3 wire system or 3 phase 4 wire configuration like. So, shunt passive filter have been considered more appropriate to mitigate the harmonic currents and parallelly to meet the reactive power requirement of these loads and to relieve AC network from the problem, especially current fed type of nonlinear load. I mean they are very you can extensively use as a shunt filter for mitigating the power quality problem by current fed load, like typically thyristor converter like used in HVDC. Thyristor converters are used like in DC drive, or thyristor converters are used to drive a current source inverter, current source, a DC current source for feeding the current source inverter, including the line commutated synchronous motor drive, large rating drive, including the typically order of 75 megawatt or 100,000 horsepower drive. So, they are used in all those applications like with the current fed kind of the load. And in voltage fed type of load, passive series filter are considered better for blocking the harmonic. I mean because in case of voltage fed kind of load, example of voltage fed kind of load we have given last time, that if you have a diode rectifier followed by a capacitor, DC link capacitor which form a constant voltage source, so that we call it the voltage fed. So, their harmonic currents flow almost like an uncontrolled harmonic currents, and the total harmonic distortion of high voltage fed kind of load is very high compared to the current fed of load. But voltage fed load normally do not require the reactive power. So, in this case what we normally prefer to use the passive series filter which really block the harmonics to flow into that. So, it work like a kind of the dam, I mean for typically for the harmonics to flow from the line to the towards the load. Right. Well, what we use in this passive power filter, normally the capacitors, AC capacitor, and we use the reactor or inductors in general, and this is typically the configuration if you can look into a passive power filter, I mean as a assemble passive filter which have a capacitors and reactors like I mean also. Coming to the classification of passive filters, I mean the classified based on topologies, connections and number of phases, and this is the typically you can think about the classification of passive power filter. I mean we classified like into the shunt, and then for the after shunt we define whether it is a band pass or tune filter. We call band pass or tune filter means it is tuned only for one particular frequency, or there is a band only where that particular frequency can only flow through this passive shunt filter, or it sucks that particular harmonic current into it like I mean. And of course, it can be now either single tune for single frequency, or it can be double tune for 2 frequency, or triple tune for 3 frequency, or it will multi tune, means in the sense you can tune it typically for multiple frequency. Of course, the number of components go on increasing, so that it suck the current of multiple harmonics like. So, either it can be for single harmonics, or to double tune means double harmonics, or triple means 3 harmonics, or it may be multiple more harmonic. So, that is about like here the loss is less because the current level for this band pass filter you can call it or tune filter, we expect the current flowing into it will be large. So, we design in such a manner the quality factor what we use in the inductor is quite high, and certainly so that the losses are not much in that case, but it only take care only one particular or 2 harmonics for which these are tuned. There is another kind of shunt, you can call it passive filter, which we call high pass or damp filter. I mean, the damp filter means damping word comes that it really damp out the typically. So, we have a like a lossy element, resistance element here, and it takes care of all higher order harmonics. So, a large higher order harmonics does not have too much energy or power associated. So, we take care by using this high pass or you can call it damp filter in parallel to the tune filter, and it can be like first order or it can be second order or third order or C type of damp filter. So, this is to cover the very wide range of the frequency spectrum higher order, so that the disturbance to communication system is not there, and all the higher order harmonics are subsidized or really sucked by the shunt filter locally, which are generated by this converter or nonlinear load at the point of common coupling. So, this also becomes like almost a mandatory requirement to use these. I mean, this you can call it high pass damp filter is also used along with the active filter also, not only like along with the passive filter, but this becomes an essential part for the rating of these components. Of course, they are used in shunt, voltage rating may be enough, but current going through them is very small, as well as power losses also very small. But you can understand for all higher order harmonics the power associated is not too much, but certainly for the network like electronic circuit or communication network, I mean even a small power can cause a reasonable disturbance or interference to the system. So, certainly we have to subsidize these all higher order harmonics also locally, and we have to use this certainly. I mean the tune filter we have a choice whether we want to use 1, 2, 3 or how many, but certainly your damp filter or high pass filter is mandatory along with the tune filter. So, that is about shunt filter, which we normally prefer to use it with the current fed load. I mean like current fed load means where you have a reactive power requirement also, as well as you have a harmonics also, like a thyristor converter used in HVDC. I have given an example also, as well as the DC drive, thyristor converter for DC drive or thyristor converter with the AC supply is used to derive with large inductor to derive a current source for current source inverter or a linear commutator inverter for very high power rating drive, including like a typically up to 75 megawatt synchronous motor drive used for highest power rating for large rating drive like So, that is about the shunt passive filter. Coming to like a series passive filter, which we discussed, the series passive filters are, of course, shunt passive filter we have at fundamental frequency as a capacitive circuit, because they normally the shunt filter are normally tuned for higher order frequency. So, at fundamental frequency they behave as a capacitive fortunately as a capacitive network, and they generate the capacitive reactive power, and most of the in general like a circuit like a thyristor converter they require reactive power of leading nature, because they generate the reactive power of lagging power. So, it fortunately matches the requirement of such applications, and they have been in practice passive shunt filter since long as like when HVDC appeared in 1954 or so. So, you will find almost like a typically a topic in most of the HVDC books also as a one chapter on this passive shunt filter. I mean passive filter or filters or passive filter, normally that is shunt filter you will find, and lot of design and lot of because they are already in practice for a long time. Coming to the another kind of passive filter, that is passive series filter. I mean they virtually you connect in series with the line and load, and they are considered effective in case of voltage fed kind of load. Voltage fed load I have already explained that if you have a diode rectifier followed by your capacitor, which are majority of load of such nature to derive a constant voltage source, because that constant DC voltage source you can feed for remaining part of the process, maybe like LED lighting, maybe like your brushless DC fan, maybe your air conditioning system where we are using or washing machine. So, most of the appliances and many such load also even adjustable speed drive like a used for voltage source inverter fed typically induction motor drive. So, now in that case we use like a typically the series filter, and we call it like a band block or tune filter. I mean we are tuning for a particular frequency, like we are connecting in series. So, that is supposed to a block or put a like a dam for those harmonics not to flow those harmonic currents into the circuit from supply to the load. And this we typically again have a same categorization here also, that it can be tuned for single frequency as a blocking single frequency, or it can be two frequency, or it can be again multi tune for multiple frequency like So, in series filter, passive series filter also we again have a high block or damp filter. High block or damp filter means it is supposed to, it can be first order or second order, and it is supposed to also the block a very wide range of the harmonics not to flow from supply to the load. So it blocks all higher harmonics like also. So that is series filter, but its application is also coming. Many cases we call it like a passive wave shaping also in some of the circuit. Because they are used in series between your supply, and even in single phase people use it for blocking a particular harmonics, because third harmonics in case of voltage fed count load in single phase is very high. So to block that, even we use the passive wave shaping, so that the current of the supply can brought close to the sine wave, and the harmonic sometime the third harmonics goes as high as maybe 70 to 90%. So you can certainly block and bring back very low value of this third harmonic by putting the typically this single tune filter, or maybe even your first order, second order, your high block or damp filter like. So that is, you can call it the second category of passive filters. They were not too popular earlier, because most of the, you can call it converter load was the current fed load, like a thyristor converter in HVDC thyristor, which I have given you example like, but your voltage fed load start appearing only after the self commuting device, when we have a voltage source inverter, and to derive a constant voltage source with the low cost, usually use the diode rectifier with the capacitive filter in either it is in power supplies, which we have given a example in the nonlinear load, or whether you have a small variable speed drive or the adjustable speed drive of medium power rating. Normally we use diode rectifier with the capacitor filter, and that behave like typically your voltage fed kind of load. So there your series passive filter is quite effective, like to block the harmonics like flowing into from supply to line. Now of course they, when at fundamental frequency, this passive tune filter, they behave like an inductive circuit. So you can call it, the inductor certainly blocks flow of harmonics. So at fundamental frequency it behave like an inductor, like also. So that is the drawback, that you have some inductive voltage drop in series with, but with the proper design certainly you can probably design in a manner that it really does not affect too much to the behavior of the load like. The third category of is the hybrid, which are hybrid, can be a hybrid of high tune and series filter, high tune of tune of your shunt and series filter, or a hybrid of tune and damp filter. So normally though you certainly use it. So this is a kind of like how you are making a hybrid of either the tune and your high pass filter, or tune and damp filter, or you are making a hybrid typically of, which is normally we use it like, or you are using a hybrid of shunt and series filter. So the plenty kind of configuration can be even in the category of your hybrid category also like also. Well, coming to like a of each individual category, just to explain about it. So let us come first of your shunt passive tune or band pass filter, and it can be like a single tune, or it can be double tune, or it can be triple tune with series capacitor, and or it can be triple tune with the series inductor. So these are like a shunt passive tune or band pass filter, which normally used in shunt with the, and you can see an example that we have a single tune. So you have a normally L and C, the circuit which is tuned for a particular frequency, like maybe third harmonics for single phase and maybe lowest fifth harmonics in three phase, can be suck into this circuit, this, because L and C are designed in such a manner for that particular harmonic, like fifth harmonic, they cancel out the reactance of each other and suck your third harmonics. Well, you are seeing another element here, resistance here. Normally this resistance is not kept separately. This resistance is a part of the inductor, because no inductor can be made without some loss, and that loss represent of this resistance is represent the loss of this inductor, whether it is like you can call it the resistive loss, because you are putting a wound field, you are putting a wind, so you are putting large number of terms which certainly have some resistance. Apart from that, you are putting normally on ferromagnetic core, okay, ferromagnetic core. So it means there will be some core losses in this inductor, okay. But of course, you are designing this inductor very properly, with the high quality factor. High quality factor means resistance is quite small in that case. The quality factor, practically people are able to even realize around 15 to 30 order of that. The quality factor we will just explain. You might have gone through quality factor virtually in the even the first year basic course of electrical engineering. We will discuss that further. So this resistance normally kept is very small, but this resistance certainly help in a manner that it limits that particular harmonic current. Of course, to limit that particular harmonic current, normally we design like a fifth harmonic filter corresponding to like a 4.7th harmonic, not fifth harmonic. There are two reasons. With the time of aging of the component, I mean it should push from 4.7 towards the fifth, like I mean or so. And little detuning certainly limits the current. I mean otherwise there you can call it, there may be I mean ideally the infinite current if completely tuned like L and C, or even a very small voltage there, and impedance if it is 0, then you will have infinite current. But practically it cannot be that. So, practically what it limits it, one is the resistance limit the current of that particular harmonics, like maybe third for single phase and fifth for, and another is this typically resistance limit the current, like I mean also. And this inductor is normally made in a manner that it should not change the voltage or current, the value of this inductor, otherwise your passive filter will not properly if inductance is changing with the voltage or current value going through it. So, what we do in that case, we put like normally a small air gap, I mean in the core, which takes most of the MMF, and certainly air gap which because of relative permeability of the ferromagnetic part and the air gap, I mean even there is a saturation, I mean even a 1% air gap in the magnetic circuit path will take total MMF of this inductor, you can call it, and even there is a saturation in ferromagnetic part that will not allow to change the inductance more than 1 or 2% like. So, that is the practical aspect or design aspect, or you can call it engineering aspect of manufacturing this and designing this inductor like. So, that is second one is the double tune that of course, you are putting a I mean like here the element correspondingly. So, it is tuned for double frequency like, okay. I mean you can tune like maybe third and fifth or seventh harmonic tune that at it can give a low impedance corresponding to typically 2 harmonics like here, not 1, I mean like or so. And then you have a triple tune. So, triple tune may be with the series capacitor, this is series capacitor with the triple tune, or it can be with the inductor with the triple tune. So, this can these two can work for 3 frequency, it can like a 5th, 7th, and then can be like a your 11th harmonics. So, all 3 for like a 3 phase system, it can be for all 3 frequency can be 1. I mean, but of course, you can call it component. I mean here if you call it, let us say, I mean for single tune it is only 2 component, but here I mean you can have like 1, 2, 3, 4, 5 component you are adding like, I mean. So, certainly the number of components is a different criteria for, I mean it depends, like we will have used in practice these kind which are appear in practice in. So, there is a passive shunt tune or band pass filter. Coming to series passive tune or band stop filter. Band stop means it is virtually particular band of frequency it is blocking, I mean stopping like, I mean. So, it can be also single tune for single frequency or double tune or double frequency. I mean like, so you can think about this like, again the resistance is not separate than the inductor, but you can connect, you can interestingly see it, the shunt filter they are connected in shunt with this, but the circuit is series. But in series filter, I mean you know it connected with the series with the line, but the elements are connected in parallel. So, that is like a typically interesting, and then only this ideally it should like suppose you are tuning it for third harmonics, okay, which practically it is used in some cases. So, ideally it should block the third harmonics completely, it means the impedance of this for third harmonics should be infinite. That is the reason third harmonic cannot flow from the source side to the load side, I mean that is the tune, or you can tune for 3 phase like maybe for 5th harmonics. So, it should offer the impedance very high for the I mean for the frequency for which it is tuned like, and this resistance is not a separate part of inductor, and here also corrective factor of this should be quite high of the inductor like, I mean also. So, here it is like again the double tune, I mean here you are just adding a one more component only, and you are able to tune for corresponding to double the frequency. So, it is supposed to block the 2 frequency, not the one only, like maybe third and fifth in case of single phase, and if it is a 3 phase you can tune for 5th and 7th like. So, it can block 5th and 7th, but keep in mind at fundamental frequency the impedance of this will be corresponding to like a inductive. So, it will take some inductive voltage drop across it like, if it is not going to harm, and that is the reason earlier it was not used, it was not too popular, I mean in the current fed load, because you are having a number one, you are why it is not with the current fed load. One is it is disturbing the operation of current fed load, because you are not allowing constant current, I mean like to flow into the DC side, and another it is I mean disturbing the typically the voltage across the current fed load. So, it is also inductive, that is also reactive. So, it means the reactive power burden further increases in current fed load, but in voltage fed load normally sometimes it is little leading reactive power, and it give a lagging reactive power or inductive circuit. So, it matches the requirement of both separate individually like. So, this single tune, double tune, and then we have a shunt passive damp filter. I mean damp or high pass filter. High pass means all higher order harmonic will pass through this, like I mean typically you can call it like, and that it can be like again first order or second order or third order or C type filter. C type filter is normally used in, even it is reported in very high rating like HVDC also. I mean it really reduces the losses because they are used for very high power. So, you can call it, this is your first order RC filter, I mean R and C. So, it is, you can call it, why it is called damp, because you will have a losses in this, and you might be seeing that even the previous topic also like DStatCom or wherever we are using a voltage source converter, we are using this filter to take care all higher order harmonics which are generated by pendulum switching, also we were using this kind of like I mean. So, you can understand for higher order harmonics, I mean like all higher order harmonics, it behave very low impedance, and for which it is tuned this become like only the resistance take, the capacitor is very small impedance, only resistance decide the total impedance of it like I mean also. And that is the reason the quality factor of this is normally kept between 0.5 to 5. In tune filter the quality factor is order of around 15 to 10 to 30, okay. But here the quality factor goes 0.5 to 5 in that range. So, you can see according to the resistance accordingly decided in that way, and you can say the impedance for higher order, all higher order harmonics equivalent to R, but you can call it in fundamental frequency, the C we have like a very large impedance. So, it will not have any fundamental frequency current, and losses also for fundamental frequency will be also quite low in this case like I mean, because if it is not drawing very large current or very small current is there, so it will not put any kind of like a reactive power burden or anything on that like. This is second order, I mean you can call it the band pass filter. I mean second order band pass filter, I mean you can call it like it can be tuned for particular frequency and it takes care of higher order harmonics also. Then third order and C type. C type you can see we have a minimum losses here because the you are using only the resistance in parallel, so most of the current might be flowing through this path, I mean you can see of higher order current typically also. So, losses in this case will be certainly reduced, that is the reason we call it like a C type I mean filter like so that is like a shunt passive damp filter or high pass filter, but normally these filters are mandatory along with the tune filter like to take care of all higher order harmonics which give interference to electron circuit as well as they give the interference to communication system, as we really use this also along with the voltage source converter, even in case of DStatCom, otherwise in active filters or active compensation also will be using this like coming to like a now. I mean this is a typical example like a current fed where we normally use. So, we use a I mean like you have a source and we have a thyristor converter and we have this passive filter. What passive filter consists like let us say 3-phase converter. So, we have a 5th and 7th tune and then we have a 11 order high pass filter. So, this is the same second order, it is also take care 11th harmonics and all higher order more than 11th like I mean because 5th 7th are here, but it should take 11th harmonics. 11th harmonics I mean typically typically taken care like as a tune kind of filter, 11th harmonic will flow through this and higher order will flow through this like also as you see there. So, this serves the purpose of a one particular harmonics and higher than all the harmonics above than that. So, that is the normally you will find lot of literature related to 6-pulse thyristor converter I mean used for like a DC drive or current fed current source inverter drive using such kind of filter 5th and 7th also, and the reactive power of course divided equally, we will talk about that in the design also. So, that is about the passive damp or high pass filter. Coming to like a typically damp filter for series, I mean like for a high block, that is typically the circuit like I mean we connect along with the earlier L and C, now we connect the resistance in parallel to this. So, that takes care all the higher order harmonics current will be blocked I mean virtually because of the. So, at typically you can call it a fundamental frequency, this also will behave just like a small inductor, it will take a very small voltage drop at fundamental frequency, but higher order harmonics because inductance will increase, reactance will increase for higher order harmonics and most of the current will be forced to flow to this, that will be also very less. So, you can call it, it will behave a large impedance corresponding to all higher order harmonics like also. So, that is virtually you can call it high series high damp or high block filter like Well, coming to the category again topology based classification with the hybrid passive filter. So, hybrid can be like a like damp double tune filter, or it can, because double tune means you are using hybrid of the two, or damp triple fold triple tune filter. So, this is you can call it one kind of hybrid filter, because you are not having only one filter tune, you are putting double tune filter, or it can be the triple tune filter like you can say. So, that is one kind of hybrid. and another of course, classification can be like a series filter, shunt filter and hybrid filter. That is another configuration, you can call it as a combination. I mean this is like a same filter, but classified a little in different way or so. And this is you can call it the classification of shunt filter. I mean what we were calling a band pass, like this was the first category which we have shown, and this is the characteristic impedance, how this impedance behave corresponding to the frequency. So, the impedance of this will be minimum at resonance frequency, and that will be equal to, because I mean reactance at that particular frequency of this capacitor and inductor will be equal, they cancel out, and it behave only resistance, and that is the minimum impedance. And the bandwidth of defined when the impedance of this is root 2 times the R, I mean you can call it here and here, this is we call it the virtually the band of this your tune filter or band pass filter like. So, in this band only you can call it the all the currents of that particular frequency will flow into this like, I mean, and this is you can call it the high pass. I mean you can see at low frequency the impedance is very high, but all other harmonics, I mean after this for which it tuned, I mean its impedance goes lower even than the R, and up to all you can call it even a infinite large harmonics also. I mean when you have a large harmonic, impedance of this go on increasing, and this resistance is constant, the impedance of this will go to very low. So, final impedance of this circuit will be only R, it cannot go more than R, but at lower frequency you can call it this inductive reactance will become let us say quite small. So, the most of the current will flow through this, but the reactance of this capacitor will become very high. So, impedance of this will be very high for low frequency like. So, this is a characteristic of, you can call it impedance characteristic with frequency for high pass. So, all high pass you can call it are flowing through this only like, and this is typically double band pass which we are talking about. So, it is tuned corresponding to two frequency like maybe fifth and seventh for 3 phase. Okay. These are the two dominant harmonics, I mean in 3 phase, or it may be like a typically you can call it like a single phase third and fifth harmonics. So, these are dominant harmonics, you can tune corresponding to that to take care by one circuit itself by both the harmonics like, or it can be like a typically we were talking about the composite which we have shown earlier. So, you have a composite means two tune filter like maybe fifth and seventh, and then you have a high pass. So, you can clearly see that fifth here, seventh here, and all harmonics correspond to this filter. So, you can call it like a 2 of this category and 1 of this category is this, and this is the actual composite what we use in practice like, I mean. So, maybe you can use the 4 tune, I mean, or maybe 2 tune, depends on the cost and complexity required like, I mean. So, but you will have a for those 2 harmonics like maybe if you are using like a typically like a 4/6 pulse converter, it may be like a your 5th harmonic, 7th harmonic, then all higher order harmonics also impedance quite small because of the this you can call it the your high pass filter like. So, this is a you can call it the impedance characteristic for your composite filter which used in practice, I mean. But for single phase you can think about this, but 3 phase you will have such 3 branches for 3 different phases for A, B, C phases like also. Well, coming to shunt filter, I mean that was typically the passive shunt filter are connected in parallel with the harmonic producing load, and they provide low impedance path for harmonic currents because they are tuned corresponding to that, and there are plenty of that nature you can call it like you can think about 5th harmonic, 7th harmonic, 11th, 13th. If you are using with the 6 pulse converter, so you are these are the 4 dominating harmonics, so you might be putting 4 dominant, and the actual basic circuit is your XR, XC, and at that particular frequency if this XC your XL5 should be equal to XC5 for 5th harmonics like. So, they should not have a like a 0 impedance for 5th harmonic, but we can call it like a quality factor of this, and resistance of this inductor will certainly will have some resistance equivalent that will block, you will offer the impedance that much of this like. So, that is like a passive shunt filter, and you can see the photograph how this passive shunter look like in HVDC. I mean HVDC converter station you might have seen, they start from 300 megawatt, and maybe in world you will have it even the maximum rating of the HVDC line have been up to typically like a 6 gigawatt means 6000 megawatt rating. So, you require on converter station that passive shunt filter of this nature like also. And type, so you can also say it like a notch filter also called as a single tune filter, or double tune filter with a double band pass filter like for high voltage application, and the high pass filter also known as a DEM filter, and shunt passive filter also have the problems of like a what is the problem of shunt passive filter. I mean this you have to take care in the design like resonance with the supply impedance, because you know don't know the supply impedance, there is a lot of literature to look into what the range your supply impedance can be there, and you have to design in a manner that there is no resonance with the supply impedance, and we have like a fixed compensation typically of this, because Fixed compensation in the sense, I mean once you have designed for a particular reactive power, so it can give only that much reactive power and it can only draw particular that much harmonics current for which it is designed for, and then poor perfector at light load. This is very interesting because you are designing this passive filter for a particular reactive power at corresponding to the full load. Okay. So, it means the reactive power considered in the design is corresponding to full load and that is some reactive power. But when you operate the load under light load, means the load is reduced, I mean from on the typically because of operational reason, I can tell you the kind of load why you are having a reduction of power flow on HVDC line, or you might be having like a adjustable speed drive with a large synchronous motor with a line commuted which current fed. So, if you are having a like a drawing the low power, I mean in that case the your current will be less. So, certainly the reactive power given by the passive filter is constant, but you now need like reduced reactive power. So, certainly it will go to poor perfector on leading side, not lagging side, leading side like So, that is I mean the one of another drawback like of it, and that is typically what you have is typically notch filter or your single tune filter also, or double tune second order damped filter which we discussed earlier also. Now, coming to series filter, I mean they provide high impedance for blocking harmonic current. At fundamental frequency, the filter is designed to offer very low impedance. Ideally, I mean you should have a 0 impedance, but it cannot have a 0 impedance. The reason being that it behave really, you can call it like a inductive component, I mean like, and these are used in a small power rating in single phase system to block dominant third harmonic, and these are typically the, you can call it like a different your passive series filter, I mean like a single tune, a block, then double tune and typically high block like I mean also. Well, coming to the configuration of hybrid filter, of course, it can be used for single phase 2 wire system, or it can be 3 phase 3 wire system or 3 phase 4 wire system. This is just basic configuration, which configuration are more popular why. I mean, so this is the one of the configuration you can think about, that we are putting a passive filter in series and passive filter in shunt with a nonlinear load. This topology we have tested, we designed it, we patented it, it is a fantastic topology. I mean like for the current voltage fed kind of the load. I mean the drawback of passive series filter is taken care by the passive shunt filter. What is the drawback of passive series filter? Because it behave like a inductive circuit at fundamental frequency, and that reactive drop is taken care by the reactive power generated by passive shunt filter. Okay. So, that drawback of passive series filter is taken by passive shunt filter, and the drawback of passive shunt filter is it has a resonance with the source impedance. Since you are putting a single block harmonic filter here, I mean that avoids the resonance with the supply system. So, this becomes a, we look into this topology, becomes a very interesting topology, and we design it, tune it, even we presented it this circuit for particular. We will like to share our I mean the result also with that and give a very fantastic performance like also. Coming to like a typically like another configuration, that your passive series you put on load side and shunt you put, but now with this can be used also with the current fed load also, not only voltage fed, it can be current fed load. Why it can be current fed? Because now you are not going to disturb the your load, and passive shunt filter meet the reactive power requirement of the load also, and the load current still can be maintained in the same manner. It is not going to affect like your supply system, because you are providing the shunt path for all those harmonics which load is drawing. I mean like, so you know to typically the block that, and whatever some harmonic you can block and some you can circuit, so it give a very fast, very interesting combination. So, and the up to some extent you can compensate the drawback of one to, I mean you can say limitations of one by another also, that I have discussed it. But in this case this is another can be in the reverse way also, but certainly this is not so attractive, because this will can be good for, you can call it like a for voltage fed kind of load, because this will block and this behave a inductive circuit. So, this can give a reactive power and some of the harmonics it can suck, but certainly the popularity of this is not gone so high. We will discuss that also, how it really offers the good combination. So, this is another hybrid filter. These are the hybrid filter of your passive, or it can be hybrid of the 3 passive. I mean one here, another here, another here. People try in practice to distribute these elements, different elements at different location. So, we call it T kind of hybrid filter, and then, or you can call it like it is a pi, I mean hybrid filter, one passive series and 2 passive shunt on both the side also. But you can understand the major limitations of this, that you have a lot of components. Think about like here, it is shown as a symbolic, but you might have a lot of components here in this tune filter, in this tune filter, as well as in series filter. So, number of components even for single phase will be reasonably high in that case, like because you have to connect at least a high pass on in these filters like also. Well, this is another supply based classification of passive, typically your power passive filters. So, they also divided in the category of like a single phase, shunt, series and hybrid, and 3 phase 3 wire again shunt, series and hybrid, and 3 phase 4 wire shunt, series and hybrid like. So, that is the classification on supply based classification, how you are going to use whether shunt or series or hybrid like also. So, coming to 2 wire, you can think about like the series filter for typically of your single phase. So, you have a like a typically for the third harmonic blocking tune corresponding to block the third, to block the fifth, and to block all higher order harmonics. But this is normally preferred, you can call it like a only in your voltage fed kind of. Only load should be voltage fed, and single phase voltage fed load are very extensively used like power supply, your typically variable speed drive with the voltage source inverter, you have a direct rectifier with capacitive filter. So, they are, and sometimes not necessarily using all the 3, like maybe sometime we use only 1 along with that or 2 out of this, and this we sometime in practice we call it like a passive wave shaping also. We are bringing this current very close to the sinusoidal by pushing passive element in series with the kind of the load. So, they are also known as a passive, you can call it a wave shaping circuit also like and this is series in 2 wire single phase, and this is the shunt, like how they are connected like a third, fifth and high pass. So, normally with the minimum configuration you are tuning third, fifth, and this you tune on 7th and all higher order. L and C are tuned for 7th, and then accordingly quality factor decided that it takes care of all hard order harmonics also. So, this becomes your, you can call it the for single phase passive shunt filter, considering like 2 dominant and third taken here, and a higher order harmonics taken care by a high pass like also. Just high block, it is high pass here. So, you can see very interesting why it is shown in this one slide. When you are connecting the filter, this series filter in series with the line, but components are in parallel. But here this shunt filter which are connecting in shunt or parallel to the load, but elements are connected in series. Okay. So, that is the interesting part to observe naturally. This phenomena comes naturally in the design and their configuration of these passive filters like also. And if you go to the 3 wire, 3 phase non load, which are very large number. You have a 3 phase direct rectifier with capacitive filter, then adjustable speed drive, using like a large number of applications like wastewater treatment plant. We were discussing where you have a unidirectional power pump, compressors, plenty of applications are there. We use air conditioning, where you are taking only unidirectional power flow. You prefer to use simple diode rectifier, and after that you have a 3 phase inverter feeding induction motor drive. So, there of course, we use 5th harmonic, 7th harmonic, 5th harmonic block, 7th harmonic block, and all, and then you can call it 11th, and all higher harmonics you block with this like also. But you can understand how many elements are there, like a 2, 2 plus 4 and 4 plus 7, 7 into 3 means your 21 elements are supposed to be taken in this passive series filter, but this is quite effective like in the sense. Or then you have a shunt similarly, that you have a 5th and 7th and then high pass like okay, that tune for like a 5th, 7th and 11th, and then all higher order harmonics of 11ths are taken here. So, these are shunt. They are normally used with the current fed of load, but you can think about the element. For each phase, this is for one phase 2 to 4 and 4 plus 3 7, 7 into 3 phases means it becomes again 21 elements like. So, so many elements are there, like your passive elements connected here, but for developing country they are very popular, and for like even like HVDC, this passive shunt filter are quite popular because they do not disturb the load, because they are connected in series. So, as far as load is concerned, load is getting like a sinusoidal supply feeding to the, but you can understand how, when this passive shunt filter will become effective, provided you should have some harmonic voltage here, and there will be some harmonic voltage. Why? Because you are drawing the harmonics current by load and there is a source impedance. So, some harmonic voltage. So, it is a relative solution, okay. You can call it engineering solution. Since harmonic voltage will be there, then only harmonic current will flow into this passive shunt filter. So, this is something like a, a kind of, then the harmonic voltage also will reduce it, because now major amount of harmonics are going into this passive filter. So, it will not appear, current will not appear. So, it will reduce current here, major current will go into here, and then you design in a manner that this current is below a certain level, so that it meets the some standard below which you have to keep the. So, that is the design criteria, because it is an engineering solution. So, you do not have an absolute solution here, you cannot completely eliminate, but certainly you can reduce the harmonics here like common also. Well, this is typically your passive in 3 phase 4 wire. So, if you are able to block the harmonics in all 3, it will not go certainly through the neutral. Are able to follow, like even 3 single phase you are tuning for 3rd, 5th and then 7th and high order. Once you are blocking 3rd here, 3rd wire the dominant in neutral. So, once you are blocking 3rd to flow into all 3 phases, okay, and then it will not flow into the neutral. So, neutral current also will be automatically compensated even in case of 3 phase 4 wire system also like. And then it here also 3 phase 4 wire shunt filters also neutral, you are connecting with the neutral of the typically. So, this is 4 wire system, this is just to give you a configuration like how it is going to be 3 phase 4 wire system. Coming to like a principle of operation of this passive power filter, the basic principle of operation of passive power filters may be explained through their objective location, connections, quality, sharpness, rating, size, cost, tuning, applications and other factors like. The objective is like the main purpose of passive shunt filters is to reduce the harmonic voltage and current in the AC power system to an acceptable level, and the basic operating principle of passive shunt harmonic filter is to suck or absorb harmonic current in low impedance path relied by using a tuned series RLC circuit. So, that losses are also not that, means you are really sucking locally this harmonic current which are drawn by the load, and the supply is relieved from those harmonic currents like, but you cannot eliminate completely, you can reduce only the this by providing the low impedance path for these harmonics like. In case of passive series filter, it is to block the harmonic currents entering into AC network by passive tuned LC circuit offering a high impedance for harmonic currents like. But for fundamental frequency we should have ideally the 0 impedance. For shunt, for fundamental frequency we must have ideally very high impedance. In finite impedance it should not draw any fundamental current from the your typically from the supply, because they are put in shunt. But certainly at fundamental frequency they behave as a capacitive network, and it give fortunately the reactive power, leading reactive power, which most of the such current fed kind of nonlinear load need the reactive power, and most of the AC network certainly have a lot of magnetic component. So, this reactive power at fundamental frequency really are acceptable or virtually preferred, which is in case of your you can call it shunt passive filter, and series filter of course it block, but ideally it should give a 0 impedance at fundamental frequency, but it offers certainly low impedance, but this is inductive inductance, because you can understand at fundamental frequency the reactance of capacitor which is connected in parallel with the inductor will become high. So, fundamental current will not flow that much into the capacitor, but major current will be flowing through the inductor. We will look into the circuit when we come to the circuit with that like. So, passive shunt filters are connected in parallel to the load and rated for the system voltage at PCC, and passive series filters are connected in between AC line and the load and rated for full load current. That is the important criteria like also. So, here the voltage rating it certainly depends because on the PCC voltage, and here current rating is decided by the load current. So, this is also another basic objective or concept to understand in the for the design. And passive filters are the engineering solution for harmonic reduction within acceptable limit and not completely elimination of harmonics. This is also very important as a objective. So, in case of passive shunt filter, the harmonic voltage are required at PCC to flow the complete harmonic currents into passive series RLC circuit of the shunt filter, and it is a passive shunt connected circuit which sucks part of harmonic currents into it and fraction of harmonic currents still flow into the network. Therefore, it only reduces harmonic currents and does not completely eliminate them. Well, location, these passive filters are located very close to the load either on AC or DC lines, and most of the time these passive filters are connected at PCC where the loads are connected. However, sometimes they are connected in tertiary winding of transformer designed for this purpose at optimum voltage to reduce the cost and to increase the effectiveness, because they are properly designed the leakage reactance of the tertiary winding. Moreover, these passive filters may be used for high voltage harmonic producing loads which require transformers and tertiary winding of the same transformer is designed to use these passive filters like. And type of connection and configuration, these passive filters are used in shunt, series and hybrid configuration, and connection and configuration may be shunt passive filter. I mean like typically as far as connection is concerned, they are connected in shunt passive shunt filter, and the passive shunt filter are tuned at a slightly lower frequency at which they suck the harmonics. Like typically fifth harmonic filter is tuned at 4.7. The reason being that at little detune it is capable of blocking, you can call it able to offer some impedance to block, you can call it not to have a kind of short circuit correspond to that harmonic, that is one purpose. And with the time when your decay of the component take place, because the impedance offered for particular harmonics is your omega equal to 1 upon under LC. So, with the time if your component value reduces like inductor reduces, so certainly the Tis tune frequency goes to higher. So, it should go to exactly towards the exactly resonance frequency like. So, that is the reason why they tune. For multiple harmonics, the multiple tune series filter circuits are used to absorb these harmonic currents. However, the voltage harmonics are also reduced at the PCC due to reduced harmonic current flowing into the AC network and less harmonic voltage drop at PCC, resulting in reduction in harmonic voltage. So, you can understand you have a source impedance, fixed source impedance. If less harmonic current flowing through this, certainly then less harmonic voltage will be produced at the point of common coupling. So, they are also responsible because you are now drawing the less harmonic currents into the source. So, certainly the less voltage distortion will take place at the point of common coupling, but certainly there should be some harmonic voltage at the point of common coupling, because otherwise your passive filter will not become effective. Passive filter cannot draw the harmonic currents because it is a passive network, LC network. So, till you have a harmonic voltage, it will not suck the harmonic current into it like also. And coming to typically again the shunt filter, for reducing the number of series circuits of passive element, a high pass filter is used in parallel to other branches to absorb all higher order harmonic currents into it, and high pass passive filter uses additional resistance in parallel to the inductor, which is offered impedance for all higher order harmonics, low impedance, that is only offer low impedance of equivalent to that resistance only. I mean because the inductor will have very large impedance for higher order harmonic, so but resistance will not change. So, all harmonic higher order harmonic currents will flow through only this resistance only. Of course, it will have a losses corresponding to that, but the energy or power associated with all higher order harmonics is quite low, I mean like in that case. Well, this resistance had the losses because of these harmonic currents. However, the higher order harmonic currents are quite low and therefore, not much loss is produced in the resistor like. Moreover, low frequency current, that is fundamental, mainly confined through the inductor, and which of you can call it like a this is reasonably inductance. So, you will not have a very large current flowing into the even inductive circuit also. So, these passive shunt filter provide leading reactive power at fundamental frequency, which fortunately an additional requirement of large rating AC-DC converter for which these filters are used. So, it matches the requirement natural manner of reactive power requirement of this AC-DC converter, which need the lagging they generate the lagging reactive power, or they require lagging reactive power, which this passive passive filter provide the leading reactive power, and they are able to meet this requirement locally for I mean in natural manner like that is the benefit. And coming to like a series filter, connection of and configuration of the series filter, the passive series filters are tuned at slightly low frequency at which they have to block harmonic current, and for mitigation of multiple harmonics, multiple parallel tune RLC circuits are used to block these harmonic current, and for reducing the number of series connected parallel tune LC circuit of passive element, a high block filter is used in series with the other branches to block all higher order harmonic current, and they are connected all in series. I mean because in parallel certainly I mean other harmonics can be affected like. And typically the high pass passive filter uses additional resistance RH in series with the capacitor, which is the lower impedance offered virtually RH for all other harmonics. So, this resistance is quite small. So, you can call it like a typically very high order impedance. This resistance has the low losses because of blocking of these harmonic current. However, higher harmonic currents are quite low and therefore, not much loss is produced in the resistance like. Moreover, low frequency current fundamental is mainly confined through the inductor, because that is the offering, and that is the reason I mentioned earlier also that the series filters, passive series filters offer as a inductive behavior in series like but you can understand in voltage kind fed of load, that really have a slightly leading, sometimes leading reactive power. We will explain sometime in detail, and that meets the requirement of this small inductive circuit like. So, these passive shunt filters having a lagging reactive power at fundamental frequency, which is undesired features, and it has inductive voltage drop at fundamental frequency, resulting in poor voltage regulation across the load. That was one of the reasons series passive filter were not popular earlier like. In addition, these passive filter have to be rated for full current, and their protection becomes an additional requirement. Therefore, these passive series filters are not very popular in practice. It also avoids the drawback of the passive filter by shunt filter and demerits of shunt filter by So, coming to configuration, connection and configuration of hybrid filter. So, hybrid filter means we are having both now series filter as well as shunt filter, and that is the features like the hybrid filters avoid the drawback of series filter by shunt filter, and demerits of shunt filters are overcome by the series filter, and it is quantified in terms of quality factor of inductor, also known as a sharpness of the tune of passive filter. Sharpness we explain with the help of quality factor of the inductor or of the circuit, and passive shunt filter is considered to be tuned corresponding to a frequency at which the inductive reactance is equal to capacitive reactance, and passive shunt filter tuned at lower frequencies are sharply tuned and have higher value of quality factor, typically order of 10 to 100, and preferably between 30 to 60 like. So, that quality factor is quite high or so, and quality factor is high, it means the resistance is small, and if resistance is small, losses is also small in this case. But practically you cannot avoid like typically losses, because still you have some resistance like. And of course, other type of passive shunt filters known as damped filter with a high pass filter are tuned for a high frequencies, and they have low value of quality factor, typically order of 0.5 to 2, and preferably their quality factor is selected between 1 and 2. That is the design criteria how really it matches, and this high pass passive filters offer low impedance over a broad band of the frequency bandwidth. And coming to the cost of this passive filter, the cost of passive filter certainly have been lower, and that is the reason it has been quite popular in developing country as well as underdeveloped country, because you can develop them locally with the passive component like inductor and capacitor, which can be easily fabricated here like. The cost of this passive filter is reasonable, and sometimes it reaches 15 to 20% of the equipment for which it is used. Therefore, the design of passive filter has to consider the cost in account while designing these passive filter. Moreover, it has some power losses which also must be considered in its design. The cost of passive filter may also be partly supplemented to the reactive power supplied by it. Well, these filters are sometimes designed based on minimum cost filter, and an overall minimum cost filter is the minimum capital cost which adequately reduces the harmonics at least cost with some part or part of reactive power. A minimum cost filter has to consider these cost of losses along with the capital cost of the filter like. The major part of the capital cost, about 60% is the cost of power capacitor. Therefore, a reasonable cost reduction may be achieved by proper choice of capacitors also.